Here we are at 8.4 part 2. Yay! Alright, let's continue working with the special log properties we had on the other page. So as we do I, J, K, and L, feel free to flip to the front and look at the properties or the formulas whenever you need to. We're going to have to think on some of these for this page here. So first I want to say, if these are matching up, I mean if you look at your formulas immediately, nothing really looks like it's going to match up. So here's where some of our math knowledge comes in. 125 is actually 5 cubed. It's actually 5 cubed. So what that means is I can use one of my properties, and really then it's log base 5 of 5. These are together. Okay, and then the log base 5 of 5 cancels, and my answer is just 3x. Part J. This is another one where if it's a common logarithm, really it has a base 10, remember. And the 10 and the log base 10 cancel, and that one's just equal to 5x then. I want to tell you as well that some of these properties are going to make more sense when we do section 8.5 and 8.6, because we're actually going to use these to solve some problems, and it will make more sense then. So you might be able to come up with the right answer right now, but you might not really understand what you're doing yet. That's okay. It'll become more clear to you as this chapter kind of goes on. Look at K, and remember common logarithm. If it doesn't have a 10, it's really base 10. Again, this is not matching really, so let's think in our minds. 10,000, that's 10 to what power would be the question, and it is actually 10 to the 4th power. That x was there from before, so again, log base 10 and 10 kind of cancel, and just 4x is my problem. And L is a simple one. The 5 and the log base 5 cancel, and just x is the answer. What we're going to do next is we're going to take the conversions from exponential form to logarithmic form, and we're going to use that to guess and check and find some answers. And this always confuses students because it'll just say evaluate, and then it'll give you something like log base 3 of 81. Here's what I would recommend. Always set it equal to x. Always set it equal to x, then convert to exponential form, then guess and check. So set it equal to x, convert to exponential form, guess and check. I set it equal to x, so let's convert it. My base stays 3. Those two switch places. And now I'm trying to figure out what power of 3 gives me 81, and here's where we're going to guess and check. So guess and check a little bit if needed. I tried 2. Well, we know that one's not going to work. That one's 9. 3, nope. 4, yeah. So the answer is 4. Let's keep going. Set it equal to x. Convert the format. There we go. Now here's where some of your previous math knowledge comes into play. When it's going from a big number to a fraction or a decimal that's under 1, the only way we can make that happen is if it's a negative exponent. So here's what I'm saying. Let's say I'm doing some guess and check action. I'm not coming up with anything. The only way I can get this power to be small enough so that it's going to be a decimal is when I go negative with my exponents. So try a few of them, and we really are just right now guessing and checking. So it seems a little bit tedious, but that's our method we're using at the moment. And 1/25th is the same thing as 0.04 if I convert to a fraction in my calculator, or back to a decimal, depending on the format it gave you. So my power I need is -2. You might want to make a little note to yourself then. When you're trying to go from a number to some sort of decimal or fraction, often it's going to be a negative exponent, so that's something you can guess and check. And here's an example of it going the other way. What's happening here, when I convert it to exponential format, I've got 1/2 to the x power equals 8. So now it's a similar situation, only these are switched. So again, so this time I'm going from a fraction to a big number, but the only way I can make that happen again is if I have a negative exponent. So if you try some things, and here is me guessing and checking a little bit, you end up getting that -3 works. So x is equal to -3. And do you see how I just tried a few things? Especially when you're just getting the hang of this, you're going to try a few things before you get the final answer, and that's okay. That's how it works. So part D, I got log base 9 of 3, convert it to exponential format. Hopefully you're starting to get the hang of that again. Okay, I converted it to exponential format, and now I've got to figure out what power of 9 gives me 3. So I know that I'm getting smaller, so in my mind maybe I'm thinking right away, I'm kind of like, okay, maybe I need a negative. Well, those are going to be too small. Try my positives. Nope, those are too big. So here is me teaching you for a little bit. You can use fractions as well. So, and specifically, they're not going to make it too hard. It's either going to be a 1/2 or a 1/3 fraction usually. And you know what? I lied because I see example H is going to be 1/5. But it's going to be something that you should kind of know. And remember that a 1/2 exponent is the same thing as square root. So in your mind, you might want to be thinking square rooting, cube rooting, fourth rooting, that kind of thing. And so my answer is actually this time 1/2. So let's just recap really quick. So the answer could be a number. It could be a negative number, it could be a fraction. So there's 3 different types of things you could get for your answer depending on your situation. And you'll have enough time that if you don't get the hang of it too much, you will have time to do some guessing and checking action. Why don't you pause right now and try E, F, G, and H and see what you can do with this. Alright, so for these examples you just tried, check your work. And you can see I gave you 1 or 2 of each of the types you'll see. So I got a whole number as my answer, a negative, a fraction. And this is something we can work more on in class. So if you got any questions right now, pause and write it down. But I want to tell you that to get these answers, I did guess and check, guess and check, guess and check. So that's how I did that. Next, natural logarithms. So a natural logarithm has a base of e. So our letter E comes in again here, and this is why this is all together. If I have a base of E, hey, okay, I accidentally hit the pause button, so I'm not really sure where I left off to you, but I had just written down log base E of x equals. So if I have a base of E, that actually is so commonly used that they have made a special button on your calculator for that, and it's the ln button. So ln of x is how I would say that. But it is still a log. It's still a log, so the logarithm, all the logarithm properties apply. It's just so commonly used that they have a special way of saying log base E. And so let me give you an example quick. Let's say I had log base E of 5. It's not going to look like that. They would write ln of 5. So sometimes when students are doing this, if that really confuses you, you can just rewrite it like this to kind of help your brain out a little bit. Your choice. Alright, let's do some calculator entry quick. So you maybe were noticing, or maybe even trying to play around with this while you're watching the video. You can see that your calculator has a log button and an ln button, right? It's on the left side right next to 7 and 4, log and ln. Now, here's the deal. If you're trying to do some of those problems with your calculator, can't do it because our calculator only has log base 10. So the log button on your calculator is the common logarithm base 10, and then the ln button is the log base e. And by the way, some of you with the newer graphing calculators, you might actually be able to type the logs in, but you will be able to have to do it without a calculator for a little bit, so practice it without that first. Alright, this next step is just straight up calculator entry. So pause, try them, write them down, and then we'll check. Alright, how'd you do? And if you didn't get those correct, you better ask me during class, because you can't ask me right now, obviously, but during class I can help you with the calculator entry if you did not get those correct. So logarithms are actually used in a lot of formulas in science class in particular, but here we have something, I've got the slope S of a beach. It's related to the average diameter of the sand particles on the beach by this equation. Kind of interesting, which makes sense though, depending on how big the sand is, sand molecules are, that determines the slope of the beach. So here's my formula. Part A, I want to find the slope of the beach if the average diameter is 0.25 millimeters. So the way that they gave us this question is, or the formula I mean, is that the variable here actually is in millimeters the diameter. So all I'm doing is straight up typing something into a formula. So instead of D, I put 0.25. This can all be entered into your calculator, and you should end up with approximately 0.088 millimeters. It's really, really small, but that makes sense, right? Because if you take a single grain of sand, it's almost not humanly possible for us to measure the diameter of that sand particle. So it is really, really small. And next, find the slope of the beach if the average diameter is 0.125 millimeters. You know what? Same type of problem, just a different number for the D. So I'm going to, again, just type in 0.125 into my formula, as long as I can write it down correctly here. Type it into my calculator, actually, and then I end up with approximately 0.0524 millimeters. Thanks for listening. We'll see you in class tomorrow. Hope you're having a great night. Bye.